So, what if our most basic understanding of space and time was all wrong? What if it's like a funhouse mirror? The kind that perfectly predicts the crazy, distorted reflection you see, but tells you absolutely nothing about what you actually look like. Today, we're diving into a really wild theory that questions the very foundation of Einstein's relativity. And it all starts with one simple question. Have we been mistaking the reflection for reality this whole time? Right. So the source material we're looking at today frames this whole debate with this amazing analogy. The argument isn't that Einstein's math is bad. Actually, it's brilliant, but maybe only at one thing, predicting the distorted image. It's like having a perfect formula for that funhouse mirror's reflection. And this is the key, a perfect formula for a distortion isn't the same thing as a formula for reality itself. And this is really where it gets provocative. Just because you can predict that banana-shaped reflection with 100% accuracy every single time, does that mean your face is actually a banana? Of course not. This theory argues that modern physics has fallen into that exact trap. We've gotten so good at predicting the reflection that we've started believing it's the real thing. So this gets us to what the source material calls the funhouse mirror problem. This is the core conflict we're exploring today, that huge difference between a model that's great at making predictions and a model that actually describes what's really going on. You see, according to this perspective, the debate isn't whether the equations in relativity give us the right answers in our experiments, because they absolutely do. The real question is, what are those equations actually describing? Are they describing the fabric of reality itself? Or are they just describing the distorted information that happens to reach our instruments? All right, so let's take a look at the established view, what this new theory would call the perfect formula for the distortion. We're going to look at the model we've all been taught, but we're going to do it through this new, pretty critical lens. And this slide just lays it all out, side by side. So on one side, you've got Einstein's view. Space-time is flexible. It can bend and warp. Things like time dilation, where time literally slows down for something moving fast, and length contraction, where it physically gets shorter. Those are real. In this view, what the observer sees is reality. But then on the other side, you have this theory's view. It says, nope, there's an absolute medium, and all those weird effects are just illusions. They're tricks of the light caused by how long it takes a signal to get to you. Here, the observer's view isn't reality. It's just a distorted map. The source even has a name for this mistake: descriptive narcissism. It's a pretty bold term, right? The idea is that an observer is moving through the universe and sees this warped picture because of signal delays. But instead of saying, hey, my view is distorted because I'm moving, they declare that space and time themselves must be bending to fit their personal observation. It's confusing your personal map with the actual territory. So if Einstein's relativity is the funhouse mirror, what's behind it? What does the real face look like? Let's dive into the alternative model this theory proposes to try and describe that. The whole theory really hinges on this one core concept: the map versus the territory. The territory is the real, objective, physical world out there. The problem is, we never get to see it directly. What we see is the map, a warped picture that gets created because light takes time to reach our eyes. And the bold claim here is that for over a century, physics has been obsessively studying the map, thinking it was the territory. To make this official, the theory lays out a three-worlds model. First up, you have the mathematical world, just pure logic, pure equations. Then you've got the physical world, the territory. This is the absolute real medium where stuff actually happens. And finally, there's the observational world, the map. That's the distorted view we get because of signal delays. The whole mistake, according to this, is that we've been mixing up world number 3 with world number 2. So what does this territory actually look like then? Well, this theory says it's not the smooth, stretchy fabric of space-time we usually imagine. Instead, try to picture a 4D point cloud. Reality isn't like a sheet of rubber, it's more like this huge invisible grid where events just happen at specific coordinates at specific moments. It's a collection of individual points, not some continuous thing. Okay, so how does this point cloud reality create the illusion of relativity that we all see and measure? Well, the source proposes this really cool mechanism it calls the event anchor. This is the key to understanding how the map gets so warped. Now, to get this, we have to be super precise about three different things. First, there's the source object itself. Let's say it's a moving train. Second, there's the emission point, what the theory calls the anchor. That's the exact coordinate in space where the train let off a flash of light. And third, you've got the light front, the signal itself. And here's the crucial part. Once that light is emitted, its behavior is tied to the anchor, that fixed point, not the moving train. This slide shows it perfectly. Just imagine a ship moving through this medium. At one specific instant, it gives off a flash of light. That exact spot in space becomes an anchor. It's now a fixed coordinate. The light wave then expands out in a perfect sphere from that fixed anchor point. Meanwhile, the ship itself keeps on moving, leaving the center of its own light wave way behind it. And this is the absolute key takeaway. The light does not follow the train. It expands from the coordinate where the train used to be. The light remembers its origin point, the anchor, not the moving object that made it. And that separation between the object and the signal it created is supposedly the source of everything we call a relativistic effect. Okay, so let's tie all of this together with a thought experiment. This is where we get right back to that Funhouse mirror and see how all these ideas create what the source calls the banana face effect. All right, here's the setup. Picture this. You're in a car, and you are flying along at 10% the speed of light. Right next to you, moving at the exact same speed, there's a train with a huge mirror on the side. So you get an idea. You grab your camera, point it at that moving mirror right next to you, and you try to take a selfie. Given everything we've just talked about, what is that picture actually going to look like? Let's break down the journey of that light. First, the light from your face can't just go straight across. It has to travel ahead to where the mirror is going to be. Second, because your face isn't just a single point, the light from your right ear travels a slightly different path for a slightly different amount of time than the light from your left ear. Third, after it bounces off, that reflected light has to travel to your camera's new future position. And the result? Your camera ends up capturing this time-smeared composite image, pieced together from light that left your face at slightly different moments in the past. And the final result is a banana face. Your camera takes all this time-smeared information and puts it back together into one picture. But because the information from different parts of your round face took different amounts of time to make the trip, your face gets reconstructed as this weird, distorted shape. It's not a physical change to you, it's an information artifact. And here we are, right back at the core disagreement. You've got this distorted image, the banana face. Standard relativity would look at that and say, yep, that's evidence. In this frame of reference, your face and space-time itself have genuinely contracted. But this theory says, no. Your face is fine, the image is distorted, and that's just because it's a map that got assembled from a bunch of delayed signals. So, is this just a fun thought experiment? Or could this alternative model offer us a totally new map of reality? Let's just wrap things up by summarizing the core argument one last time. So, to be perfectly clear, this theory is not saying that relativistic effects aren't real. That banana face is a real thing you would observe. The entire debate is about what causes it. Is space-time itself literally stretching and shrinking like standard relativity tells us? Or are we just seeing a geometric illusion? A totally predictable distortion that's created by signals moving at a finite speed through an absolute, unchanging medium? And that leaves us with this final kind of mind-blowing question. This theory suggests that pretty much everything we see through our telescopes and in our particle accelerators, it's all just a distorted map. If that's even possibly true, then what does the underlying territory, the real unfiltered reality, actually look like?